Hi, everybody. It's meteorologist Joe Chaffee for meteorologistjoechaffee.com, weatherlongisland.com, and to be launched later today, nycweathernow.com. We are looking at the GFS model, and we have a post that will be that goes with this video. But before we get to the model, I just want to show you on the water vapor loop of Category 5, Hurricane Matthew with top winds of 160 miles an hour. It's been moving on a course to the west-southwest, but it looks like in the last hour or so, at least it seems like the movement is a little bit more westerly. So that southwest motion may be almost done. So we'll continue to watch to see if this westerly motion now takes over. And then, of course, the next thing we're going to look for is that gradual turn to the northwest. We looked at the last reconnaissance aircraft report that came in, which was the one that matched up with the Hurricane Center's advisory, so we really don't have too much new. There's probably going to be an eye wall replacement cycle. What that is, you can't hold peak intensity for so long, so what winds up happening is that the eye wall degenerates and weakens, and then it refires up. So during that cycle, you'll actually see the storm's pressures go up a little bit, and sometimes it may go up more than just a little bit. And if, assuming conditions are still favorable, it would more than likely strengthen again. So it's possible that we may have seen the first level of rapid intensification where the hurricane kind of levels off, and then it weakens just a little bit, and then possibly could re-strengthen, but we'll see. Okay, so let's go to tonight's GFS model run. And I want to just say right off the bat that when you look at these model runs, they are not forecasts. This is a model output takes the data, runs it through its computers, and this is the outcome that it has on this particular run. So we'll just move forward, and you can see here's Matthew. Here's the upper low. I'm using this region so that we can get a look at what's going on. You can see that weakness here that shows up quite well right in there. So here's that upper trough, and then you have the ridge, the Atlantic ridge right here, okay? And the weakness is right in between, right there. So, well, there's that weakness. Now it's going to track close to where that upper ridge is. So it's going to do something like this. I'll probably have it a little bit too far to the west on the way I drew it, but the bottom line is that that's where the weakness is, and that's where it's going to be headed. So the model, and by the way, over time, that what I just drew would have assumed that the ridge would hold still, but you can see that the ridge kind of gives way a little bit further to the east, and that means that Matthew moves more northwest or north-northwest, and then heads right over the island of Jamaica. It looks like on this run it takes it over the eastern half of the island, probably as a Category 4 hurricane, and then over eastern Cuba, and then out it goes into the Bahamas. Now you can just see the beginnings of the trough in the west. Now I'm going to switch to a wider view. We'll go to let's go to the U.S. view, because this way we can pick up the whole trough. Now, here's what's happening. You have this deep trough out in the plains that's moving into the moving out of the Rockies and into the plain states. We're now at Wednesday afternoon, by the way. Here's Matthew in the Bahamas. You have a big ridge now that's building up in the northeast with a large surface high that's probably sitting near Nova Scotia. So we have a very strong onshore flow that sets up and down the east coast. So this trough, Matthew, and the ridge. So there are your players. You also have the Atlantic ridge right here. So there's a weakness right in this area. So I would think that this is where we would probably see Matthew try and move toward. Now, as we move along, again, and I want to caution again, this is the model's output based on the data it sees now. We've seen it go back and forth. That trough swings east. Matthew straddles the coast of Florida and the southeast coast of the United States. Now the trough and Matthew on this particular run meet up just it times out just perfectly. Okay, so you can see it there. There's the trough. Here's Matthew, and they're basically going to do a phase on this run. So, you know, it's amazing that the model timed out the way it did. So what we have on it on the surface is, and I'll just back it up so you can take a look. And you know, I'm hesitant to show this because I don't want someone to interpret this to say that this is what I'm forecasting. I'm not forecasting this. I'm just showing you what the model's doing. It straddles it up the coast, and then because it phases it, it takes it pretty much north-northeast, almost like a wintertime nor'easter, and has the center touching eastern Long Island and going up into New England and then into eastern Canada. So this would be a week from today if this were right. Now, I want to also tell you that the European had a totally different solution because it timed out. This was the European from yesterday. We don't have the new European yet, but it timed out everything differently. It was much slower with Matthew, so that trough was not nearly as deep, and Matthew gets left behind. So what we're going to have to do is evaluate all the other models as they come in tonight, and of course we're going to go through this process all over again during Saturday and on Sunday and on Monday. So until we get a consistency in these model runs, and until we figure out, by the way, we've got to figure out the trough that's coming into the plains. That's really important. I'm going to widen out to this North America view. And here's the situation with that trough. It swings in. Now, there's energy in the Pacific Northwest, and models have been disagreeing about that. The GFS, to a lesser extent than the European, is holding energy back off the West Coast. So that allows this ridge to build. If you look at some of my prior videos, we talked about this. It allows this ridge to build, and it has this trough pretty well intact. So as it swings around, it sharpens up and picks Matthew up. If something comes into the Pacific Northwest and crashes the ridge, like for example, if we go back 2 model runs for the same time frame, you can see that the timing was different. Matthew was kicked out because the timing's not the same. The ridge is not nearly as strong in the west. Now, the 3 model run trends have been further and further left, closer and closer to the coast. So, I will start to gain some confidence in what I'm looking at when I start to see the European coming around to this idea. And you know what? While we have it, since it should be out far enough, I think it's all sporadic. It isn't out far enough. Maybe it's. Let me see if we can get another region. We'll look at the Canadian, which I have to admit is not the most reliable model. See, in the Canadian, I can see right now times it all differently. It leaves more of a trough behind in the northeast, and you can see where it goes. It actually takes it northeastward out of the Bahamas. Okay, and here comes the trough, but it's too far west, so by the time it picks it up, it's southeast of Cape Cod. So we'll show you the surface of this. Different than the GFS. And of course, the criticism I will get from this is the fact that the Canadian is probably the most unreliable run, and it is. But I want to look at it since we have it. And there you can see it's much further offshore. And then it makes kind of a northward turn so that it goes into eastern Maine. It's almost like what the GFS did about 5 or 6 runs ago. So I don't know if it's playing catch up, and we're going to see it gradually go further and further west over time. I haven't been paying attention to the Canadian too much over the last few days, so it's hard for me to decipher what that model trend is. So there you have it with tonight's weather models. We'll evaluate what the European did in the morning, and I do have the web posts for you to look at where you can read more extensively about what the GFS model does on meteorologistjoechaffee.com. A link comes up right here at the end of this video, and don't forget to check the websites. And I'm on a Facebook also. There's a Facebook link right on the YouTube page. You can go ahead and, if you're not on my Facebook page, go ahead and like the page. And of course, please subscribe to my YouTube page, as it really helps me out with my standing with Google, and it doesn't cost you a dime. Have a great Saturday.